So now we're going to go further into solutions, and we're going to look at electrolytes. So this is a type of solution. An electrolyte is basically something that when dissolved in water, it breaks up into ions and creates electricity. The electrolyte, kind of like electricity. So a good example is sodium chloride. When sodium chloride is dissolved in water, it breaks up into Na plus and Cl minus, okay? Anytime you have free ions like that, so charges in solution, it creates electricity. And you can actually, if I go to this next slide here, do you see here this image here? So you put salt in water, these free ions that move around, okay? If you put electrodes in there, it'll actually turn on a light bulb. There's enough ions free in there floating around that it creates enough electricity to light a light bulb. Whereas sugar, on the other hand, when you put sugar in water, it dissolves, but it does not break up into ions. Sugar just stays as a solid, okay? Does not break up into ions, so it's called a non-electrolyte, meaning it will not conduct electricity because it doesn't break up into ions. So if you look at this picture here, put sugar in there instead, no light bulb will light up. And if you look at this video right here, if you want to click on it, you can actually see a video of a professor showing a light bulb lighting up when put in salt. Okay, so basically a strong electrolyte will break up fully into ions and conduct electricity. Okay, a weak electrolyte, as the name implies, okay, only partially breaks up into ions, and so doesn't really conduct electricity very well. Either sometimes it'll light up a light bulb, but it's like so faint you can barely even see it. So a good example of that is a weak acid or base. You see, only 5% will actually break up into the ions. And the non-electrolyte, meaning it won't break up into ions at all, okay? And so then it gets into, how do you know if it'll break up into ions or not? How do I know if it's a weak or strong electrolyte? Well, there's rules to follow. And these are your solubility rules. So basically, if a compound fully dissolves in water, then pretty much it's going to be a strong electrolyte. If it does not, then it's going to be a non-electrolyte. These are rules just to be memorized. Okay, so I'll kind of go over them, read of them a little bit. So it says, for example, if you have ammonium, NH4, in a compound, all salts of ammonium are soluble in water. Okay? If we're looking at sodium and potassium, all salts of sodium and potassium are soluble. And we're always looking in water. If we're looking at nitrate, all nitrates are soluble. So anytime you see these in a ionic compound, it's going to be soluble. Anytime you see an acetate ion, so these are kind of like your polyatomics, all of them are soluble except for iron 3. And that one actually will say is a solid, and so will be a non-electrolyte. Okay? Chlorine, bromine, iodine, they say all are soluble except for silver, mercury, and lead. Okay, so if they're mixed with those, they're not soluble. If you look at sulfates, all are soluble except the ones in calcium, barium, and lead. PO4, so your phosphates, carbonates, and sulfites, only aren't soluble really at all except in NH4. But we saw up here all NH4s are soluble. And then OH, only alkyl metals and NH4 are soluble. Okay. So those are some rules. So let's apply these rules. So basically we want to see, will this dissolve in water and form an electrolyte? Okay. So let's look up lead chloride. Okay, PbCl2. So we come over here and we see that it has chlorine in there. Okay, so let's see what the rule says. All chlorides are soluble except those of silver, mercury, and lead. So this is a lead, so it's not soluble. So this would be insoluble or non-electrolyte. Look up copper chloride. Okay, so again, this is a chlorine. And let's look up if it says anything special about copper. All chlorides are soluble except those of silver, mercury, and lead. Well, since it's not silver, mercury, or lead, that means it is soluble. Okay? So this one is soluble and it's a electrolyte. Let's look up barium sulfate. Okay? Here's a sulfate, SO4. It says all sulfates are soluble except calcium, barium, or lead. So this is a barium sulfate, so it says it's not soluble. So not soluble. Meaning it will not dissolve in water, it'll be a non-electrolyte. Okay? So find some portion, either you're looking for barium or you're looking for sulfate on here. Notice on the side here, I don't see barium, but I do see the sulfate, so I read the rule and just decide, okay, will that sulfate be soluble or not? And then I looked at the next one. Copper chloride. I look for copper. It's not listed here, so then I'm going to look for chlorine. Chlorine's right there, and I read the rule and decide if it's soluble or not. And so that's how you use the solubility rules. For the next podcast, what we're going to do is apply these in a reaction, okay? We need to decide if we mix these two things together, will it be soluble or insoluble?